I'm Colin Walls, and I'm here once again to talk about embedded software. Today, I'm going to look at C++ again. C++ is still something of a minority language in the world of embedded software. Most developers still are more attached to C, and are sometimes a bit afraid of some of the C++ functionality or worried about overheads and so forth. But the language does have some great features which we ought to take a look at. And today I want to address a couple of questions that have been put to me not so long ago, which highlight some of those features. So the first question is, how are default parameters useful? Now, default parameter is simply a trailing parameter to a function which is given a value such that if you don't include that parameter in a call to the function, the default value is assigned to it. The general point here is that you can simplify function calls by giving them less parameters and therefore make the code that little bit more readable potentially. Let's look at an example of this. An example where function calls can be quite complex is the API to a real-time operating system. The example I'm going to use is using the Nucleus real-time operating system, which enables you to create a semaphore. And you do that using the create semaphore API, and here is the prototype. Now, as you see, there are 4 parameters to it. You pass a pointer to the control block, you give the semaphore a textual name, you give it an initial count, because a semaphore can be binary or it could be a counting semaphore. And lastly, you give it a suspend type. There's different ways that task suspension can be handled. Now, it turns out that it's not uncommon for most semaphores in an application to be binary semaphores, so you want an initial count of 1, and it's quite likely that the suspend type will be priority. So what we can do, in C++ anyway, in the prototype, is we can add those values. So here we see we've set the initial count to 1, and we set the suspend type to priority. Now, normally, if we made a call to this API, it would look like this. We'd include all 4 parameters. So we've included our pointer to the control block and our textual name and the value 1 and the value NU priority. But now we have these default parameters, we can shorten the API call to look like this, which includes the vital information and thus makes the code a little more readable. And that is a priority for all developers, is making code as readable as possible. That's really important. That feature, I should say, in C++ has no overheads associated with it at all. There's no cost to using it. So if you feel it's making your code clearer, go ahead and use it. The other feature I wanted to spend a few minutes on is constructors. And the question is, why might you use multiple constructors? Now, constructors are special functions, special methods as we call them, which are included in a class such that when you create an instance of the class, an object, the constructor is called when that object is created, usually to do some kind of initialization. A destructor would be called when the object goes out of scope. Now, you would normally have a single constructor, and that's the function that's called whenever the object is created. But it's quite possible to overload the constructor function and provide multiple options. And this makes sense when there are different ways that you might initialize the object. This is best shown by example. So here I have a class which does something to do with angles. We don't need to know what the class as a whole is to do with. Angles, of course, can be expressed in radians or in degrees, minutes and seconds. We have the choice. So we'll have 2 constructors, one with a float value, which is the value in radians, and the other one with integer parameters for degrees, minutes and seconds. And we'll use default parameters as well, which enables us to call this constructor with 1, 2 or 3 parameters depending how much precision we want to give to the angle. So here are some examples of declaring objects of this type. In the first one, we are declaring it with a value in radians, and the progressive ones show degrees, minutes and seconds, then just degrees and minutes, and then just degrees. So this gives us lots of flexibilities, again making the code more readable. It's necessary to appreciate that you can't put in a fractional number of degrees, but then you wouldn't normally do that. If you're using degrees, you use them as integers, and then you use minutes and seconds. So it makes sense. There are other possibilities one could include, and it's quite likely that an application you have requires more flexible initialization like this. So that's it for today. 2 more C++ topics which I hope I have clarified. I'm sure there'll be more in the future. But that's it for today. So I'll say bye for now.